countdown, but now we're recording. If you don't have anything, let me mention just a couple of things that I've seen come across as emails. And these have been emails that were sent to all students, so you should have gotten them too. So I want to make sure that you have seen them, you understand them, or you respond to them. The first of these, there are actually a couple of them I'm going to combine into one. There was an email that came out about the Space Center, I believe it was, and how it's open for business, doing tutoring, virtual tutoring, and I'm not suggesting that any of you need it. What I'm suggesting more is that you may be some of the best tutors we have on campus because you're in trig. There's a lot of people that don't ever make it to trig. That means you've done equivalent to 098, you've done equivalent to 100, you've done equivalent to Math 112. You're way ahead of the curve in just about all the students on campus. So you would probably make excellent math tutors. Okay, so something to consider. However, if you do feel like you need tutoring, that's there for you too. Now, it's not just there. There's also tutoring offered by the STEM lab, and you don't have to be on campus for any of this. It's all can be done virtually. The STEM is science, technology, engineering, and math. If any of you are a STEM major, and I'm guessing many of you are, any science major, that could be biology, chemistry, physics, any science major, technology, that could be computer science or any related major like that, engineering, of course, any engineering major, and finally mathematics or anything to do with that. Now, I hope I said physics when I said the sciences. Okay, any of those majors, the STEM program is looking to get, especially since we're not on campus, Dr. Thomas can't recruit students easily, so she asked us for any of our good budding upcoming students that may be in those majors. If any of you are there, please contact Dr. Shawanda Thomas, that's S. Thomas at lawsonstate.edu. The STEM program offers some fantastic benefits, okay? You get to participate in research opportunities. You get to participate in tutoring opportunities. You get to hang around with a bunch of really like-minded folks, that you can probably learn a lot from, and building camaraderie. And it's a federal grant, and they get to travel. They get to do lots of things that are incredibly rewarding. So if you're at all interested, please get in touch with Dr. Thomas. Okay, I've given a couple of your names to her when she was asking, but I said I would have to wait until I get the first test results in before I could give you any more. But just judging from homeworks and things like this, I knew a couple of you I thought were potentially heading in that direction. So not only this Space Center or the STEM program, there's also tutoring offered by Student Support Services. It's all virtual, and at least two of those, I think maybe all three, do use peer tutors. Okay, now, and like I said, I think you could be some of the best tutors we have on campus. Here's the deal. Yes, you're helping other students. That is worthy. Okay, that's worth it just there to do tutoring. But let me tell you something else. All of these, if they use peer tutors, they pay peer tutors. So especially if you're somewhat strapped now, you're stuck to your home, your things are social distance, stuff like this, you can actually make some money right there at home. It's pretty good rate. I think it's right at the minimum wage type rate, but you get to set your own hours. You don't have to do it. There's no strings attached. Just show up when you tell them you're going to be showing up. And here comes Courtney. Let me get him in here. Okay. Courtney's here. Okay. That should get me up, I think. Let me just see. Yep, 15 students. I'm pretty sure that's what I've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Got it. Okay. So, so there is, you're helping others. That's positive, very positive. You may be getting paid. That's really positive. But here's the other positive. I'll just give you my experience. You know how I learn math the most? By helping others in math. Okay? If I learned a lot of math by sitting under good teachers, good professors and stuff like that. Yes, I learned a lot. I learned a lot more when I did my homework, and did that and did it for myself. But you know where I really felt like I got so where I knew the math? When I had to explain it to somebody else. That's how I got, I think, pretty good at math. Wasn't my doing, wasn't just all natural ability. It's the fact that I tutored. I tutored in high school, I tutored in college, I was on the dorm floor, I was a counselor in a dorm floor, and when I was college, later senior counselor, resident advisor, all the way along I tutored. Okay, just students. I wasn't getting paid or anything else, just the guys in my hall or the new guys in my hall. Okay, that's how I learned my math. Okay, please give it a shot. Okay, if you need tutoring, go to one of those 3 places. But if you might consider being a tutor, go to one of those 3 places. It's very rewarding, financially, helping others, helping yourself. Okay, now another thing that came across on an email recently was graduation application. I'm guessing some of you are probably getting fairly close to the point of thinking about finishing at Lawson. Are any of you graduating either this term or next term? Anybody? Okay. Okay, so Azora, you are. Is it this term or next term? Next term. This term. Okay. I know if you're graduating this term, you need to get an application in as soon as you can. Okay. The deadline, I don't know what the deadline is, but it's getting close. Okay. There was an email that came out. Check your emails. It's from the records office, or it's from Miss Chisholm. It's someone in the records office, and it outlines what you need to do. There's like 2 or 3 steps to the process. So read that email, do the steps. If you have any questions, respond to that email, or send a message to, or email to records. That's RECORDS, records at lawsonstate.edu. Someone will get back in touch with you right away. Now, if you're graduating in the spring, I'm not as sure. I know in the old days, back before Banner, they highly encouraged students to apply to graduate the term before they were going to graduate, and that way someone could review your records, review your degree plan with you, and make sure that of all the courses you might be missing that you need to graduate, that gives you time to do that before spring. You could sign up for those classes in the spring to make sure you're ready to graduate. This new system, Banner, I don't know if they have that capability. One of the students in my last class said she didn't think so, because she tried to apply to graduate in the spring and couldn't see how to do it. I told her to contact the records office, but what you need to do if you are graduating in the spring, get with your advisor or an advisor and make sure everything is in order. And if so, get in touch with the records office and see if you can start the process. Even if you can't apply yet, you can start the process. There's a couple steps before you apply. So check on that. Maybe you can't do anything till next term, but you definitely need to see an advisor to make sure you are right where you need to be able to graduate, and what courses you need to take in the spring. This past weekend, I spent almost the entire weekend working on the spring schedule. And then I had a meeting yesterday on the spring schedule. So they're trying to get it out as soon as they can. So it's going to be popping up there sometime soon. Be sure you get the courses you need to graduate. If you're planning to graduate in spring, make sure you've got them. So that's the big news there. All right, any other questions, issues, concerns? All right, if not, we are in section chapter 4, trigonometry. We're in section 4.4, trigonometric functions of any angle. Okay, and we just got started on it last time, page 288. We got the first part covered. We're ready to do example 1. So here we have a point. Let -3, 4 be a point on the terminal side of some angle theta. Okay, find the cosine, the sine, the cosine, and the tangent of theta. Well, let me remind you of what we did last time. Okay, now I'm going to draw an ugly little rendition of an axis here. Not as ugly as some of them are, but it's ugly enough. Okay, I'm going to go out here 1, 2, 3, 4, 5 spaces. Up here 1, 2, 3, 4, 5 spaces. Over here 1, 2, 3, 4, 5 spaces. Down here 1, 2, 3, 4, 5 spaces. Now, there's a reason for that. I'm going to try to draw a circle. I don't draw circles well, but I'm going to try to draw a circle. Now, this is not a unit circle. This is what I call a 5 circle. That's not a very pretty circle, is it? Nowhere close. Let's find the point. -3, that means you go to the left 3 and go down 4. That would be somewhere right about there. What in the world is that about? This is so bizarre. Okay, wait. Here's Sharika coming in. Let me get Sharika here first, and then I'll go back and try to figure out why in the world this is trying to shut down. Sharika is here. Now the bottom part of the alphabet is basically catching up with the top part. They're here strong. It's just a couple people in the middle. Okay, who are we missing? Well, I think Kelsey's gone. Not Kelly, but Kelsey. And James is the only one missing that's been here regularly lately. So I hope he comes in now. I think what it's going to try to do is shut down. Now, I want to say keep, but that's going to keep it permanently. So I'm going to have to say discard. And when I do that, it's going to shut down. So now I have to bring it back up. Okay. Why it did that, I am not sure. And it erased my ugly drawing. Okay. So let me try it again, folks. You know, this time I'm going to try a slightly different approach to it. This time I'm going to draw the circle first. And I don't draw circles very well, obviously. And I'm going to then try to do my axes in the middle of the circle. Now I'm going to space them out. That will be 2, 3, 4, and 1. This will be 2, 3, 4, and 1. This will be 2, 3, 4, and 1. This will be 2, 3, 4, and 1. They aren't very, and those are my 5s out there. So where am I? -3 on the x-axis, 4 on the y-axis. Okay, that's about where we are. Okay, I'm not exactly in the right place, but pretty close. So let that be the point on the terminal side of your angle theta. Remember, your initial side, for it to be in standard form, is always the positive x-axis. So that's your initial side. So your angle theta, whoa, here's Terrell. He must have had to go out and come back in because I already had Terrell here today. Okay. Say that again. Was that something for me? Oh, is it just someone's microphone on? Okay. All right. So here's the terminal side, or somewhere down there is the terminal side if I could get my pen to draw. There we go. So here is the angle theta that we're talking about. There's your angle theta. So -3,4 is on the terminal side. That's not an acute angle. That's not even an obtuse angle. That's a big old angle there, okay? It says find the sine, the cosine, and the tangent of that function, okay? Well, here is the point, -3, 4, okay? There's one thing we're missing, folks, and I've got it on there. I've said it several times, but you may not have realized what I was doing. What is it we're missing? Let me tell you. This is the x. This is the y. What are we missing? The r. What is the r here? Anybody? 5. Remember, this is 5 here, 5 there, 5 there, 5 there. The radius is 5. Radius, number 1, always positive. Always positive. Okay? How did I get that? 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, the square root of 25 is 5. That's how you get your r. X squared plus y squared, square root of that. Okay? So now they're asking for sine, cosine, and tangent. So what is the sine of that angle theta? What's the cosine of that angle theta? What is the tangent of that angle theta? And at the same time, we can go on and do the cotangent of that angle theta. We can do the secant. That's supposed to be a theta there, not an e. Okay? We can do the secant of that angle theta. And we can do the cosecant of that angle theta while we're doing it. Does anyone remember what the formula for any old angle that corresponds to a point xy, and that xy basically tells you what the r is? What is the sine of that angle theta? Anyone remember? In terms of x, wherever my pen is here, oh, here it is. In terms of x, y, and r, what is sine? Anyone recall? We had it last time. Y over, no, you're doing unit circle. We're not on the unit circle anymore. We're not in Kansas anymore, Dorothy. We're on the 5 circle. That's the radius. How about cotangent? What would that be? Anybody? X over r. What's tangent? Y over x. Divide these two, right? What's cotangent? Reciprocal of tangent. What's secant? R over x, reciprocal of cosine. And what's cosecant? R over y, reciprocal of sine. So all we have to do, fill in the blanks. Y is 4. R is 5. What is wrong with that picture? I'm in the wrong quadrant, people. 4 is up here. I'm in a -4. And nobody was going to correct me on that. You're just letting me go and look really foolish here. Here's where we are, folks. That's our theta here. Whoops. That's the theta. I can't erase anything here. This is all garbage. This is -3, 4. Our r is still 5. But everything else, I was going to say, sine isn't positive in the 3rd quadrant. We're not in the 3rd quadrant anymore. We're in the 2nd quadrant. This is our theta right here. Here's the theta. Okay? So it's 4 over 5. Cosine is -3 over 5, because it's -3 over r, x over r. Tangent is -4 over 3. Yes, 4 over -3, or you can pull the minus on the outside. What would cotangent be? Perfect. Negative 3 over 4. What would the secant be? Perfect. And what would the cosecant be? Perfect. Okay. Now I want you to notice a few things besides my errors, okay? Notice, okay? Sines and cosines are always between -1 and 1. This is negative, but it's less than, or it's greater than -1. This is positive, but it's less than +1. Sines and cosines are always between -1 and 1, which puts secant and cosecant always outside of -1 to 1. So this secant is negative, so it's below -1. This one's positive, so it has to be above +1. Two things to note there. Tangent and cotangent can be any numbers in the world, so there's no real pattern there, except they're reciprocals of each other. The other thing I want you to notice is, in any of these other quadrants, 2, where we are now, 3, where for some reason I thought we were, but we weren't, and 4, any of these 3 quadrants here, you're going to have 4 of your trig functions, if I can get the pen to show up, to be negative, and only 2 to be positive. In the first quadrant, they're all positive, okay? But in quadrants 2, 3, and 4, 4 out of the 6 are going to be negative, okay? Now the ones that are going to be positive, of course, in the first quadrant is all of them. Where's my pen? There it is. All of them here. Only the sine and its reciprocal, cosecant. The tangent in the third quadrant and its reciprocal, cotangent. And in the fourth quadrant, the cosine and its reciprocal, secant. Notice the reciprocal functions always have the same sign. Sine and cosecant, if the sine's plus, the cosecant's plus. Cosine and secant, if the cosine's minus, the secant's minus. And tangent and cotangent, they're always the same sign and reciprocals of each other. So here's how I remember this. I mean, I just remember it, but acrostic is all students take calculus, or all students take chemistry, or all state technical college, or I mean, to come up with your own acrostic, but that's how you remember. We are in the second quadrant, so therefore sine and its reciprocal, cosecant, are positive. Just a few things to note, okay? Sorry about drawing the wrong point, the wrong angle, the wrong everything to begin with, okay? Now, let's see how they did it. Here's their drawing, and they only went -3 on x and +4 on y. They didn't tell you, but this is your r. They showed the r, but they didn't calculate it yet. That's the radius. We know that's 5, okay? And that's the first thing you see, because x is -3 and y is positive 4. The r is the square root of x squared plus y squared, which is the square root of -3 squared plus 4 squared, which is square root of 25, which is 5. Never plus or minus, 5. R is always positive. Remember that. Principal square root here. Principal square root. Principal square root. No plus or minus in that case. Okay? Now, once you have those 3, you have the x, you have the y, you have the r, you're ready to go to town. The sign is the y over r, opposite over hypotenuse. Remember, on the unit circle, the r was always 1, and that's why whoever answered y, you were thinking unit circle. But unit circle is a very special case where r is equal to 1. In any other case, it's y over r. Opposite over hypotenuse. Y is the opposite side. Your hypotenuse is your r. Hypotenuse is always positive. R is always positive. x's and y's can be positive or negative. So that's 4 over 5 cosine x over r, which is minus 3/5. Now, as someone was noting before, you could either put the minus with the 3 or out front. Sometimes you could put it down in the denominator, but if you only have one, it's usually handier, I find, to put it out front. That's more obvious there. Okay, and tangent then would be y over x, which would be negative 3 over 4 or negative 3/4. Okay. Now, they didn't do the other ones. We did, but there's no extra charge for doing them. That would just be reciprocal here. Cotangent would be negative 3/4. Secant would be negative 5/3. And cosecant would be 5/4. 2 out of the 4 positive if you're in quadrants 2, 3, or 4. Okay. Your sine and its reciprocal cosecant are positive in the second quadrant. Tangent and its reciprocal cotangent are positive in the third quadrant, and cosine and its reciprocal secant are positive in the fourth quadrant. Everything's positive, in the first quadrant. I've been talking since 8:30 this morning, and my throat's about to give out on me. So, excuse me just a second. In between classes, I went downstairs to get something to drink, and my wife was just returning from the grocery store. She tries to go very early in the morning so she encounters the fewest number of people, and everything hopefully is clean from the previous night. Anything that may have been deposited the previous day is died, so she does that. So she just got back from the store, so I had to help her get stuff in. Wound up not getting anything to drink, so sorry about that. So there is what example 1 is asking for. The signs, here's what I was saying before, of the trigonometric functions in the 4 quadrants can be determined from those definitions of the functions. For example, because cosine is x over r, r is always positive. If x is positive, that would be first quadrant, everything's positive there, or fourth quadrant, cosine would have to be positive. So it would be positive in quadrants 1 and 4. Everything's positive in quadrant 1, but cosine and its reciprocal secant are the only two that are positive in quadrant 4. Okay? That's what we already said. They're reinforcing it. All right, and here it goes again. In a similar manner, you can verify the results shown in this figure. Everything's positive in the first quadrant, including the reciprocals. Cotangent, secant, and cosecant are all positive. Everything's positive in the first quadrant. The second quadrant of the big 3, sine is positive, cosine and tangent are negative. That means cotangent's negative, secant's negative, but cosecant is positive because it's the reciprocal of sine. Quadrant 3, all students take. That would be tangent positive. That means cotangent's positive. Cosine and secant are negative. Sine and cosecant are negative. Quadrant 4, chemistry or calculus or college or whatever you want that to stand for. The C, the cosine is positive, therefore the secant is positive. But the tangent and cotangent are negative, the sine and cosecant are negative. So good to remember. And this shows why everything's positive here, because x is positive, y is positive, and of course r is always positive. Over here, x is negative, y is positive, so the things that depend on y and r only. My internet connection is unstable, so I'm going to quit talking trig. Did I break up some there in the middle? Yay or nay? A little bit. Okay. My internet, it said, was unstable. Last time I looked, my internet was 5 bars, so it's not my internet. Well, it may be the internet system, but it wasn't my internet here at home, so who knows. This doesn't look like it's stormy weather or anything, so I don't know why. Down here, both x is negative and y is negative. So what depends on x and y only? Tangent and cotangent. Negative divided by negative is positive. So cotangent and tangent and cotangent are positive here. Everything else is negative because what depends on x and r is always positive, is secant and cosine and secant, so they're negative here. Sine and cosecant, they're negative here too. And over here, of course, x is positive, y is negative. So anything that depends on x and r only, that's cosine and secant, are positive here. Everything else that depends on y and y and x, or y and r, since both x and r are positive but y is negative, they're going to be negative here. Sine, cosecant, and tangent, cotangent. Alright, and they reinforce what your angles are here: 0 to pi halves to pi, pi to 3 halves pi, and 3 halves pi to 2 pi. Okay. Beat that to death, didn't we? Okay. Now, we did example 1. They're skipping example 2 and 3. So let's back up a slide and do example 2 and 3. I have to get the book in my lap. It's a heavy old thing here. All right. Let me get I go to the wrong pad. I got a pad on my computer and the Wacom pad. My finger works on the computer pad. The pen works on the Wacom pad, and sometimes I try to do otherwise. Looks like we've got 16 students here now. Let me make sure that's right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Got it. Good deal. So we're only missing, who was it I said? James. Is that right? Yeah. So hopefully he will be coming in. But that's great attendance, folks. Great attendance. All right. Let me click on this. Now, going to have to spend a little bit of time moving stuff around. There's a taskbar here that's in the way. Oops. What was that? Still 16 students, so I guess that's fine. Jalen, you're a little bit in the way. I'm going to scoot you to, oh, you weren't bad. Okay. The other thing I've got to do is move my whiteboard. Now, from what I understand, your whole board looks white. Not mine. It's not partitioned because Zoom puts your names over on the right hand side, and I just put the taskbar up high, but then the Zoom taskbar is down low. I move it as far up and to the left as possible, so there we have it. Now, here's what they gave us. Tangent theta is equal to negative 5/4. I can't write. Okay, time out right there. Where could we be, Waldo? Could we possibly be in the first quadrant? No. Everything's positive in the first quadrant, so we can't possibly be in the first quadrant. Could we be in the second quadrant? Yes, we could be. Tangent is negative in the second quadrant. Could we be in the third quadrant? No. Tangent is positive in the third quadrant. All students take calculus, okay? Tangent is positive down there. Could we be in the fourth quadrant? Yes, we could. So this right here tells me that either we're in the second quadrant or we're in the fourth quadrant. One or the other. Okay? Let's go on. And cosine of theta, they don't tell us what it is, they just tell us it is positive. Okay, where are we now, Waldo? Cosine's positive either in the first quadrant or the fourth quadrant. Tangent is negative either in the second quadrant or fourth quadrant. Guess where we are? Fourth quadrant. Gotta be. That's what these two pieces of information tell us. Given that, find sine of theta, and they say secant of theta. But guess what? Let's just find all of them. We already know what tangent is, so let's find what sine is. That's what they're asking for. Let's find out what cosine is. They didn't ask for that, but we're going to find out what it is. We already know what tangent is. That's minus 5/4. And it's real easy to know what cotangent theta is. We'll come back to that in a minute. They're asking for secant theta, and we certainly will give them that. And once we know sine theta, which they're asking for, it's going to be pretty easy to do cosecant theta. That's supposed to be a C there. It's pretty ugly, isn't it? Okay. Now, since I'm asking for all of them, I want you to tell me what the easiest one to give the answer for. Come on, it's pretty. Yes, the cotangent, because it's reciprocal. So that would be what? Perfect. Perfect, perfect, perfect. Okay, now, the rest of them we need to know one other piece of information. Well, maybe a couple things. First, they told us what tangent was. Can you tell me what tangent is in terms of x, y, and r? What is tangent? Anybody? Y over x. You are good at it. Okay. Now, this thing up here told us that we were in the fourth quadrant, remember? That's what we learned from here. We're in the fourth quadrant. Quadrant 4. Tell me the signs of things in the fourth quadrant. As an XY pair, what are the signs? Fourth quadrant. What? Okay, the tangent is negative, but give me the signs of your x and y. In the fourth quadrant, they're both not negative. Third quadrant, they're both negative. Fourth quadrant, the x is positive because it's to the right of the y-axis. The y is negative because you're below the x-axis, right? Yay or nay? Okay, so since y is negative, you could write this, and I'm going to do it, even though I tended not to before. This is a negative 5 over a positive 4, because the x is positive, the y is negative. And this is the same thing here. This would be a 4 over negative 5. If it's helpful, you can write it that way. Most of the time I like to write the minus sign out front, but just reminding you, the x is negative. The y is negative. I put them back. No, I did them right. Okay. The y is negative. The x is positive. Okay. Now, what else do we need? Everything else here has something else in it besides an x and a y. What are we missing? Say again? The radius. And what is r? R is equal to, say again? Okay, now one problem with the radius being 3. Remember I said the other name for radius is the hypotenuse? You're trying to make this a 3, 4, 5 triangle. Guess what? In that case, the 5 is always the hypotenuse. This is your negative. Can't be that. What is r? The square root of x squared plus y squared. And we know what those are. We just identified them right here. The y is negative 5, the x is positive 4. So this is the square root of and that's the principal square root. 4 squared is 16, plus 5 squared is 25. Did someone say the square root of 41? Perfect. Ooh, ugly number, but true. So you tell me what sine is then. Sine is y over r, right? And what was our y? Negative 5 over root 41. Now, I'm perfectly happy with having radicals in the denominator, so I don't have to rewrite that. But if you don't like it, you could write this as minus 5 root 41 divided by 41. I just see no reason to do the extra writing. Can anyone tell me what cosine is? Perfect, 4 over the square root of 41. Are you happy to leave it that way, or you want it with the denominator rationalized? Okay, I do too. All right, then let's you pick secant or cosecant. I really don't care too much. Secant. What is secant? You got it. What is secant? Square root of 41 over 4. Perfect. And then what would cosecant be? Yeah, or negative the square root of 41 over 5. You can put that negative anywhere you want to. Preferably yuck, this thing is so aggravating. I don't think you can see it, but mine, because my finger happened to bump a button on the Wacom board, which I appreciate having the Wacom board, it hung up on me. So that's why I was fussing there. It doesn't matter where you put it. I like the minus out front. You could have put it down here with the 5. That was what was negative, but there we have them. We got all 5 of them. They were asking for this one in particular, and either one of these two answers would be perfectly fine, or this one, and that would be that. And this one, there's no rationalization involved because the denominator is already rational. 4. Okay. All right to have a rational in the numerator. So let's see what the book got. Sine was negative 5 over root 41, just like y'all said, and they left it that way. They actually calculated what it was. Okay. So I'm going to turn on my handy dandy calculator. It's actually my phone. And get my calculator out there. Now, since I'm using my phone, that's the cheap calculator. That's the one without anything but adding, subtracting, multiplying, dividing. We got to take a radical or square root. So I got to turn it sideways. You know this. That makes it sort of like a scientific calculator. Okay? Now, the square root thing on this iPhone is right there. I think it is. I don't know if you can get close enough to see. It's a 2 up here, index of 2. That's a cube root there. This is the y-th root of x here. So we want this one. So I'm going to do, on this calculator on my phone, I have to enter the number first, like 5, then change its sign, the plus minus, and then divide that by, and I have to enter the 41 before I enter the square root signal. And when I do that, then I press equal, and that's what we got, and sure enough, it's a negative value, negative 0.78 approximately. Guess what else? It's between -1 and 1. Sine and cosine always have to be that. Secant, though, is root 41 over 4. So again, I have to do the 41, take the square root of it, okay, and then divide that by 4. What's the things to remember that? That's right around 1.6, okay? What to remember there? Number one, secant is always either greater than positive 1 or less than negative 1. It can't be between minus 1 and 1. It can be minus 1, it can be 1, but it can't be anywhere inside. Always has to be outside. Okay? And that makes sense. And since cosine is positive in the fourth quadrant, so is secant. So they get 1.6008. That's what I got. And for sine, I already erased mine, but it was the same answer. I said negative 0.78. They put 7009. Doesn't matter. All right. There's always a checkpoint after every problem. Example, I mean. So please do the checkpoints as soon as you can outside of class. Okay? All right. Let's move on to example 3. So I'm going to clear my screen here. Okay. Don't know that I'll need it again, but I'm going to put it on charge just in case I need it later. Okay. Can I erase this one? Okay. I just heard a bip. I don't know what the bip was about. Let me clear the drawing here, and let's see if someone else came into class. 16 people here. Is that what I had before? I have a good memory. It's just real short. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, I have it right. So I don't know what all the noise is about. Okay. Let's move on to example 3. Evaluate the cosine. So this time we're looking for cosine. That's one thing. And the tangent. That's the second thing we're looking for. At the quadrantal angles of theta equal 0, pi halves, pi, and 3 halves pi. Pretty ugly writing, but okay. So first let's do cosine of 0. Now where are we, Waldo, when we're at cosine 0? You're at your x value is at its max, r. Your y value is 0, and your radius is r. So guess what cosine of 0 is? Anybody? 1. It's r over r. X over r. X is r is r, y is 0, so it's x over r, which is r over r, 1. Okay, how about tangent of theta, of 0, sorry. Well, tangent was y, and the y here is 0, right? You're not up or down when you're at angle 0. The angle 0, you're neither up or down, so the y is 0, and the x is r. 0 over r is 0. Okay? How about at pi halves? What's the cosine of pi halves? Pi halves, you're up here. And what's cosine? X, well here the x is non-existent. It's 0. 0 over r. So this is 0. But what is the tangent at pi halves? Anybody? It's your y, which is r in this case, over your x, which is non-existent, 0. Undefined. Can't do it. You can't divide by 0. R divided by 0, undefined. Okay, how about cosine of pi? At this quadrantal angle, here you are out here. Okay, your x value is negative r, your y value is 0, your r value is r, right? Well, that's negative r over r, which is negative 1. What's your tangent there? I can't get the pi to right, okay? Tangent of pi, that's the y value, which is 0, over the x value, which is r. 0 r is still 0. How about 3/2 pi? Cosine of 3 pi over 2. Where are you, Waldo? Here's where you are. You're directly down south here. Okay? Your x value is 0. Your y value is negative r. And your r value is r. So cosine is x over r. That would be 0 because your x value is 0. How about the tangent of 3/2 pi? What would that be?
Negative r over r.
Okay. No. No. Yes, you got it. R over 0. Okay. Or you're right. No, you're right the first time. Negative r over 0. Which it doesn't matter because that is undefined again. Okay. You can't divide by 0. Okay. So your tangent at those two quadrantal angles are undefined. Your cosine at those two are 0. The tangent at the horizontal quadrantal angles is 0, and your cosines there are either plus or minus 1. Okay. Any questions on that? All right, there is a checkpoint, and it's a pretty easy, straightforward checkpoint. It's very similar to that one. Please do the checkpoints as soon as you can after class is over, is when I think it works best. All right, now let's move to our good old reference angles. Go back to the PowerPoint. Okay, and we'll go back to current slide, which is that one. So let's now figure out what in the world we're talking about with the reference angles. Now, so far, they've either given us enough information that we can figure out the trig functions, or they've given us real simple things like the quadrantal angles or something like that. But you know, sometimes you don't have all that information. So what do you do then? The values of the trig functions of angles greater than 90 degrees, greater than pi halves, or less than 0, meaning negative angles there, can be determined from the values at corresponding acute angles. See, acute angles are so easy. Acute angles, all the trig functions are positive, right? So if you could deal with acute angles only, these are called the reference angles. So here's a definition, their definition of a reference angle, and then I'll give you mine. And they're basically the same. Let theta be an angle in standard position. So it starts at the positive x-axis. So if it's in the first quadrant, it's there. Second quadrant is there. Third quadrant is down there. Fourth quadrant over there. Okay? Any standard position. Okay? The initial side, positive x-axis, terminal side, wherever it is. The reference angle of that angle theta is the acute angle theta prime. So if you see a theta prime here in this book, that's what they mean. In some texts, they'll be called theta sub r, not prime, but sub r for a reference angle. Excuse me. Excuse me, I can't talk. Sorry, yesterday afternoon, man, I was having to drink something about every 5 or 10 minutes because my voice was just going on me. Hanging in a little better today, but not too much. Okay. All right. The reference angle is the acute angle theta prime, and like I said, in some texts you'll see it called theta sub r for reference angle. My internet connection is unstable. Hang on a while until that clears. Did I break up some in there? Maybe, maybe not. Okay, that acute angle is formed by the terminal side of theta and the closest horizontal axis. The acute angle between the terminal side of theta and the horizontal axis. So let's take a look at what they're talking about. Of course, if you're in the first quadrant, the angle itself is its reference angle, okay, because it's an acute angle. But if you're over in the second quadrant, the reference angle is the angle between that terminal side and the x-axis. It happens to be the negative x-axis here. Well, what does this angle, this reference angle, this acute angle theta here, have to do with that one? Well, the two of these add together to be pi, or 180 degrees. So therefore, the reference angle is either pi minus your original angle or 180 minus your original angle. That's how you figure out what it is. Has to be positive. Since 180 is greater than this angle, it's 180 minus the angle theta, or pi minus theta. What if you're down here in quadrant 3 then? Here is the reference angle from your terminal side to the closest, the acute angle to the horizontal axis. Okay, there it is. So what's the relation of this angle to this angle? Well, in this case, your reference angle plus 180 degrees is equal to this angle. So therefore, the reference angle is this angle minus 180 degrees, because it has to be positive. And since this angle is greater than 180 degrees or greater than pi, you subtract pi or 180 degrees from it to get that positive acute angle. Well, what if you're over here in the fourth quadrant? Where's your reference angle? Between the terminal side and your closest horizontal axis, that would be the positive horizontal axis here. That's your reference angle. That's an acute angle. Okay? And since that has to be positive, you go 2 pi, which is all the way to here, minus your theta, and that gives you exactly that reference angle there. 2 pi minus theta, or 360 degrees minus theta. That's how you get your reference angle. So what do? I usually draw the angle I'm interested in, find the closest acute angle to the horizontal axis, okay, and figure out what its measure is. I know this one, the theta here, or here, or here. To calculate the other, I just see. How does it, oh, wait, Kelly must have had to go out and come back in. So here she is. Now we're up to 17 people. Is that what we had before? Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Now I'm a little, oh, no. I bet Kelly was in under 2 different names. She was trying to be a spy or something. Okay.
It actually logged me out. I had to just get back in.
Okay, great. Glad you made it back. My internet went weak a little bit there, so maybe yours was doing the same. So this is how we define our reference angles. Okay? Now, why are we doing this? Well, acute angles are easier to work with than obtuse or big angles. Okay? So reference angles are usually pretty easy to work with. I can't get it to advance till I click on the slide, then advance. Okay, so here we're going to find some reference angles. reference angle theta prime, or theta sub r if you prefer it that way, of the angle theta. Theta equal 300 degrees. Well, where are you, Waldo, if you're at angle 300 degrees? What quadrant are you in? First quadrant is 0 to 90. You're not in there. Second quadrant is 90 to 180. You're not in there. Third quadrant is 180 to 270. You're not in there. So guess where you are? Fourth quadrant. Okay? Now, how far do you have to go to get to the closest horizontal x-axis? Well, one horizontal x-axis is way back there at 180. Oh, that's way too far. The closer one is at 0 or 360. So that's where you go. So guess what your reference angle is? 60. Okay? I lost my pen here. Okay? So basically, what I do is I think of the circle, and it can be a unit circle, any kind of circle. Okay, I don't draw circles well. That's pretty lousy. Now let's just try to make a good guess of. Okay, if you're 300 degrees, that means you're down here somewhere. You're 30 degrees past 270, 60 degrees short of here, so that's it. This angle here is, this angle here, it just will not write. It writes one side, then drops it. That angle would be 60 degrees. Okay, this is your 360 here. I mean 300 here. And you're just 30 degrees past the 270. Okay, so you're 60 short of 360. That's your reference angle. So the theta prime here is equal to 60 degrees. Alright. Uh-oh, what in the world do we mean by this? Theta is equal to 2.3. 2.3 what? Anybody? Anyone? 2.3. What are we? Radians, exactly. It doesn't have a degree symbol, so it must be radians. You're absolutely right. Okay? Now, we got to think. I don't think in terms of radians too well. Here's the one I know really well. This one from here to here is pi radians, right? Well, pi is 3.1415 or 16. Let's just call it 16. Okay, 159, blah, 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 blah. I can't remember all the digits. Well, this is less than that, obviously. Well, let's take half of that, and your 90 degree here would be, half of that would be 1.07, right? Yeah, 1.57. Sorry, I can't divide. 1.57 approximately, okay? Approximately 1.57. So where are we? We're between 1.57 radians and 3.14 radians. You're somewhere here in the second quadrant. I don't know where, but somewhere in the second quadrant. Here is your theta equal to 2.3. Okay? Now, what's your reference angle? Where is the closest horizontal axis to that? Right down here. So basically right down here is pi. So your theta r, or theta prime, I'm used to calling it theta r, theta prime is equal to pi minus 2.3. And if you wanted to write that out, that's 3.14 minus 2.3. That's about 0.8. That's about what your reference angle is. Now, I think the book Sorry, my throat's closing up again. Um, they carry a lot more digits than what is really allowed here, because 2.3 only has 2 digits, only to the nearest tenth, and yet they give an answer to the nearest 10,000ths. Okay, so not very fair. They say 0.8416. Okay, zero point 0.8 is good enough. Uh-oh. Where in the world is negative 135 degrees? Where do you go from there? Negative means you go down. Okay, you go clockwise. From your initial side, which is positive x-axis, go here. If I go this far, that's negative 90 degrees. If I go all the way to here, that's negative 180 degrees. It's somewhere in between. So you're somewhere in the third quadrant. That's where you are, Waldo. Okay? So what's your reference angle? It's the difference between this angle, 135, and 180. Okay? Or negative 180. But don't sweat it. It's just that positive angle's there. So do 180 and subtract 135 from it. And that gives you 45 degrees. And that, sure enough, is that reference angle. Reference angles are always positive, always acute. Remember that. Always positive, always acute. So let's see how they did it. I think we already know. The first one, you're in quadrant 4. So you go from the positive x-axis, which is in that quadrant, we'll call it 360 degrees. Subtract your 300 from it, and you're at 60 degrees. There's your reference angle. In the B part, oh wait, and here's how they draw it. Similar to what mine was. This angle is 300 degrees. That's 90, 180, 270, 30 more here. That leaves you 60 to go. So that's your reference angle is 60 degrees. Now my internet connection is unstable again, so I'm going to just hang on. Did I break up there some? Okay, sorry about that. Let me get something else to drink. Goodness gracious, I don't know what's going wrong. I've got another class before lunch too, so let's see, we go until, whoa, just 2 more minutes, is that right? Oh no, how could time fly so fast? Let's finish this problem. Okay, that one was 60 degrees. The next one, 2.3 radians has to be between pi halves radians, which is 1.57. That's what I said. They said 1.5708. It doesn't matter. It's in between that and pi, which is 3.1416. And you see, to get pi halves, you just take half of this. Half of 3 is 1. Half of 11 is 5. Half of 14 is 7. Half of 1 is 0. And half of 16 is 8. So that's how they got that. So you're somewhere in the second quadrant between pi halves and pi. And there's something beeping. Don't guess anyone came or went. Okay. It follows that you're in the second quadrant, so the reference angle would be to the nearest horizontal axis would be at pi. So subtract this from pi. And if you're doing significant digits, you round this to 3.1. Okay. This, if they had said this is 2.300, then that would be very correct to do it this way. They say approximate, that's okay. All right. Then the third, oh, and here's the picture of it. You're over here somewhere, 2.3, and the distance you had to go from there is the pi minus 2.3. All right. Now this one, they go all the way around their elbows to get to the ears, but it's okay. It says first determine that negative 135 is coterminal with 225. Yeah, you could do it that way. You just add 360 to 135, you get 225. That's one way to do it, but why not you just go around in the negative direction, see you're in the third quadrant, which was what we found. The closest x-axis there is how far you are from 220, well, from 135 to 180. Forgetting about the signs, how far is that? It's 45 degrees. That's your reference angle. And here's the picture showing this. This is the negative 135. They go up here and make it 225 and then say that's the difference between that is 45. If you did it this way, that's negative 135. This is here is 45 also. Remembering reference angles are always acute, always positive. Okay. Now, that was example 4. The checkpoint is there. We're going to start next time. Yep, we've run out of time. With trigonometric functions of real numbers. Okay, which is what we've been doing all along. Now, I don't see a mark at all on this page. I can't believe I've never stopped here before, but evidently I did. So let me get my paper in place, and we are just right. Well, got a couple pages to go. Homework exercises here would be either 9 or 11. They're both at Calc Chat. 11's at Calc View. This is beginning on page 294. Any of the odds, 13 to 17. They're all at Calc Chat. 19 or 21, both at Calc Chat. Any of the odds, 23 to 31. They're all at Calc Chat. 25's at Calc View. Either 33 or 35, they're both at Calc Chat. 33's at Calc View. 37 or any of the odds 37 to 45, they're all at Calc Chat. 39's at Calc View. Any of the odds 47 to 53, all at Calc Chat. 51's at Calc View. Any of the odds 55 to 67, they're all at Calc Chat. 55's at Calc View. Let's see. I may have jumped the gun a little bit. I got carried away there. What's that again?
We are in week 5.
Yeah, we're just ending week 5 today. We'll be in week 6 next time. Stop somewhere in there. Do as many as you can. If they get a little confusing to you, stop, and we will figure it out from there. Okay? Because what we do next time will carry on from where we were. All right. Any questions? Other questions? Now, the question I have for you, we have about 3 pages left to do to finish 4.4. Do you want me to go on and load the first test out there for you so you can start working on it? Or would you rather wait until we finish this section on Tuesday and then I put it out there for you? You let me know. Anybody? Anyone have a preference? Would you like the extra?
Can we wait till we finish?
Absolutely. Okay, we'll just wait until we finish 4.4, which I think will be on Tuesday, and then I'll put the first test out there for you. Okay, good deal. All right, good deal, folks. Any other questions, issues, problems? I'm going to stop sharing because I'm sick and tired of sharing. No, I'm just kidding. Any questions? Good attendance today, folks. All but one person showed up. That's great. So if there are no questions, I'm going to go on and end the meeting for all of us. So you be careful this weekend. The virus is still out there. I think I told you before, one of my students in my Cal 3 class has it. He's not really all that sick, so he's been coming to class, but he can't. He's isolated for a quarantine for at least 14 days. His roommate is quarantined too. They're trying to stay distance apart, so far his roommate hasn't caught it. However, one of my instructors' sons, they sent them back. Yeah, I mean, they said they had to go to school, so they sent him to school. Guess what? He brought it home without any symptoms whatsoever, so he didn't know he had it, gave it to his mom. The mom is really, really sick. So, and the husband, my instructor, is quarantined at home with her. He's having to take care of her. And the last I heard, he was coming down with something that sounds like he has it too. So it's nothing to play with, folks. Be safe, be careful. It's going to be a pretty weekend, I think, but don't get carried away. Be safe. Any issues? Take care. Bye-bye.